Okay, so let's try this question number 6 from the 9709 May-June 23 paper 5-2. All right, so in a group of 25 people, there are 6 swimmers, 8 cyclists, and 11 runners. Each person competes in only one of these sports. A team of 7 people is selected from these 25 people to take part in a competition. Find the number of different ways in which a team of 7 can be selected if it consists of exactly one swimmer, 4 cyclists, at least 4 cyclists, and at most 2 runners. Right, okay. So this is a combination problem because they want us to select a team, right? So let's take a look at different cases because we have at least 4 cyclists and at most 2 runners. So when we have one swimmer, four cyclists, so we have 5 people already. So that means we have 2 more runners over here. Another possible combination could be where we have one swimmer, 5 cyclists, and 1 runner. Another possible combination could be one swimmer, 6 cyclists, and 0 runners. Right? So let's see what are their corresponding combinations. So one swimmer out of 6 times by 4 cyclists out of 8, and from 11 runners we are selecting 2 plus 6C1, again 8C5 times by 11C1, and 6C1 times by 8C6 times by 11C0. All right, so let's find out each one of them. So 6C1 times by 8C4 times by 11C2. We get this. Now 11C1, 8C5, and 6C1. So 3, 6, 9, 6. And then 11C0 and 8C6. We get 168. So 168 plus 3696 plus 23100. So we get 26964 number of ways. So we can also write it like this: 6C1 times by 8C4 times by 11C2 plus 6C1 times by 8C5 times by 11C1 plus 6C1 times by 8C6. Right, okay. Now on to the part B. For another competition, a team of 9 people consists of 2 swimmers, 3 cyclists, and 4 runners. The team members stand in line for a photograph. So the team, okay, they stand in line for a photograph. How many different arrangements are there? If 9 people, if the swimmers stand together, the cyclists stand together, and the runners stand together. 4 runners. Right, so this means that we have 3 units of these groups, 3 factorial, and internally there will be permutations also, so because we're talking about the arrangements. So times by 2 factorial times by 3 factorial times by 4 factorial. So 6, 2, 6, 24. So 6 times by 2 times by 6 times by 24. So we have 178. Right, okay. How many different arrangements are there of 9 people if none of the cyclists stand next to each other? Now, this is a tricky question, and we'll do it 2 ways. So we have 9 people, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, if we find out the total combinations, total arrangements are 9 factorial, right? So since none of the cyclists have to stand together, then we can start by thinking when none of the 3 cyclists are with each other. So 3 cyclists together, we get 1, 2, 3, 4, 5, 6, 7 factorial times by 3 factorial because there are 3 cyclists inside. Now, since none of the cyclists are standing together, we also have to consider the possibility of 2 cyclists together and the other cyclists have to be away. So 2 cyclists together and 1 cyclist away. So we have, so 1 cyclist, for example, could be anywhere. So we have, if we think of this as, since we are losing 3, so let's do this 3 over here. So we have 1, 2, 3, 4, 5, 6. How many were there? Yeah, right, okay. So 2 cyclists stand together as 1. So this means that we have, again, 2 C's somewhere and 1 C somewhere else. So 1 C. So 1, 2, 3, 4, 5, 6, 7. Oh, sorry. So we have 2 cyclists away, 1 cyclist away, and then 6 other people away. So for the 6 people, we can do 6 factorial. So 1, 2, 3, 4, 5. So we have 6 choices for the other people. And for the 2 cyclists together, we have 1, 2, 3, 4, 5, 6, 6 choices for the 2 C's. But if I have, 7 choices, let's say 7 choices. So if I have 7 choices for the 2 cyclist group, that means the other cyclist has to be away, so it's 1 less than that. Sorry, 7. So 7 times by 6. And the 2 cyclists, they have their own permutation. So we have 3 cyclists and we have a group of 2 cyclists. So 6 factorial is for the people other than the cyclists. Then we have 7 choices to place two group of 2 cyclists. And the other cyclist obviously will be in any other place other than 2C, so it will have 6 choices rather than 7 because one of the places will be occupied by the group of 2 cyclists. So times by 6. And then the internal permutations for the permutations for cyclists, because we have 3 cyclists and we want 2 cyclists to be together. So we subtract these together. So 9 factorial minus 7 factorial times by 3 factorial uh, minus 6 factorial times by 7 times by 6 times by 3p2. So 9 factorial minus 7 factorial times by 3 factorial minus 6 factorial times by 7 times by 6 times by 3 p2. So this is 151200. Now there's an alternate easier way to do this also. So let's see that. Alternative solution for this also. So since we don't want the cyclists to stand together, we have 6 other places. 1, 2, 3, 4, 5, 6. So again, 6, 5, 4, 3, 2, 1, which is equal to 6 factorial for the non-cyclists, right? For the non-cyclists. And then the cyclists have 1, 2, 3, 4, 5, 6, 7 places to fill in. So we have 7 places to fill in and 3 cyclists. So 7p3. So 7 choices do we have, 7 places for the 3 cyclists. So that's what this is. So 6 factorial times by 7 p3. So 15120. So this is simpler, but this method is also fine. This method is also fine, so you could also try that. All right, bye bye. Let's see you at another question.